Hi guys, so here we're going to talk about one of the most important things you need to know as a chemistry student, and it's how to name compounds. So you'll need your notes, which is a pen and paper, and the periodic table. So let's kind of go through what the types of atoms are. So when we're looking at our periodic table, and if yours is blank, now's the time to color it in. Find the staircase. That staircase starts like at group 13, ends at group between 16 and 17, and it's just that dark line between those elements. Those elements that are bordering the staircase are the metalloids. So the things I have in here in gray are metalloids. It's the elements that are touching either the sides or the top or bottom of the staircase. Everything except for aluminum and polonium. The ones here in blue are going to be our nonmetals. And everything else here that's not colored in are going to be our metals. Other things we need to know about are states of matter. So we know that bromine and mercury are going to be liquids at standard temperature and pressure. Now we're going to look at gases. We use the rule 17, so element number 1, which is hydrogen, then you start at element 7, which is nitrogen, and form the number 7. So see on the right hand side we have that 7 forming, again starting at nitrogen, going all the way to the right and down to the bottom. Next we look at element number 17, which is chlorine. So that rule 17 again helps us figure out what gases are. The only thing that isn't in that rule 17 that still is a gas is helium. So don't forget about little helium up there. So I've kind of created this little flowchart to help you figure out how to name these elements or name these compounds. So you might want to do this flowchart on a scrap piece of paper first and then kind of copy it right into your notes. So what I do is I look at the number of different elements in the molecule. There might be one element, two elements, or three or more elements in there. If it's one element, I'm going to check to see if it's a metal or a nonmetal. Remember, the nonmetals are the elements to the right of the staircase that aren't the metalloids, and it also includes hydrogen. The metals are everything else except for those. If it's a metal, actually I'll go back, sorry. If it's a metal, I'll just name it as is. So for example, if it's Cu, I'll just name it as copper. If it's Fe, iron. So those are when they're all by themselves. Those metals are not attached to anything else. If it's going to be a nonmetal, I'm checking to see if it's one of the diatomic molecules, and those are the Hunkelbriefs. So hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Again, they're diatomic molecules, and they occur, if they're not combined with any other element, they're all by themselves, they'll actually have a pair of their own. So it'll be H2, O2, N2, Cl2, etc. And these will all be gases, except for bromine, which is a liquid, as we saw before, and iodine, which is going to be a solid. If it's not one of the Hunkelbriefs, but still a nonmetal, name it as is. So for example, neon, Ne. You just name it as neon. And you have to go back to the states of matter from the periodic table we just showed you guys to figure out, again, with the states of matter, if it's going to be a solid, liquid, or gas. The next thing is checking to see if there are two elements. So if there are two elements and one of them happens to be a metal, it's going to be an ionic compound. This is what we did in Unit 1. If there's two elements and both of which are nonmetals, we have some choices here. They can be binary covalent compounds, which is the beginning of Unit 2. They can be a hydrocarbon if it's just carbon and hydrogen, so make sure you write down just carbon and hydrogen. Or they can be acids. If they're acids, they're off of Table K, and we'll look at those. If we have three elements, we have to check to see if one of them is off of, or actually, excuse me, two of them might be off of Table E. Those are the polyatomic ions. So we'll again check Table E, and that's going to be an ionic compound with a polyatomic ion. If it has three or more elements and it's not off of Table E, and they're all going to be nonmetals, those are going to be organic compounds, and we'll use Table R to help us name those. So going through and quickly determining how to name ionic compounds. Binary ionic means that there's going to be just one metal and one nonmetal. The metal goes first, and if it has only one oxidation state, meaning only one charge off of the reference table, you have to check the periodic table just to make sure, then we are going to name it as this. So for example, here we have potassium chloride. The metal goes first. I'm going to look at potassium and double checking to make sure that up here in the upper right hand corner there's only one charge there. It happens to be a +1. So potassium is going to be K +1. Chlorine, it's a group 17, so that's going to be a -1. And since it's a 1-to-1 charge, it's just going to be KCl. Okay, so make sure that gets down. The next one is Li2O, and this one should be another example. You can get rid of that. Li2O. So we have to figure out how to name this. Li is lithium, and there's only one charge there, so we don't need to put any parentheses, so we can name this lithium. And oxygen is going to become oxide, so I changed the ending to be IDE. Here I have MgBr2. I look up Mg because that's the metal. It only has one oxidation state. In this case, it's +2. So I know that's magnesium. And that Br is bromine. It changes to bromide because the nonmetal changes it to an IDE ending. So again, all of these only had one number listed in the upper right-hand corner of their periodic table. Now we're going to look at metals that have more than one oxidation state, or more than one charge listed. And here we need to make sure that we use parentheses. So here I have Sn, tin. It can be a +2 or +4, as shown up here. So I'm going to see what tin 2 chloride is. I have to go back and write out the formula. So I have Sn, and that 2 shows me it's a +2 charge. Cl is a -1 charge. So I'm going to crisscross them. So there's only going to be one Sn. I'm not going to bring down that negative because you can't have a negative number of atoms. And there's going to be 2 chlorines. So this changes to SnCl2. I didn't need to put the 1 down because it's just implied there. Alright, so that's how I'd write out tin 2 chloride. If I was given a formula and needed to write out the name, I would also go back through and figure out which one of these I'm using, if it's a +2 or +4. So I'm going to use both scenarios, if it's Sn +2 or Sn +4. So I know oxygen is -2, it's in group 16, so I'll crisscross each of these. The first one ends up being Sn2O2. When you reduce it down, it's SNO. The second one ends up being SN2 and O4. When you reduce that down, it ends up being SNO2. And if my formula were correct, that's actually what it should have looked like. Sorry, darlings. Anyway, so it should have been SNO2. Okay. That would have matched up had I written my formula down correctly the first time. Sorry. Alright. The other ones that we have are with ternary ionic compounds. So this is when we have more than more than 2 atoms in here. One of which has to be positive, which is the cation, and the other one has to be negative, which is the anion. I'm going to use table E to check to see if any of them are listed up there. So, for example, if I have a ternary ionic with one oxidation state, here's MgSO4. I have 3 atoms there, an Mg, an S, and an O. I'm going to check to see if any of these in a combination are listed in table E. So by looking at table E, and it's pretty tiny on there, but you can see it on yours, SO4 is actually going to be a sulfate. So I have Mg, and I'll check the oxidation state. Yep, Mg only has one oxidation state. Oops. And that happens to be a +2. So I know Mg is +2. SO4 from table E was actually SO4 -2. When you crisscross them, it's a 1-to-1 ratio. So this is named magnesium. And I'm just taking the name from table E for the, in this case, the anion, or the polyatomic ion that I have here, and that's sulfate. So magnesium sulfate. Next, I have NH4OH. So if you look off of table E, there's an NH4 right there, that's ammonium, but I also have an OH, that's hydroxide. There's only one charge listed for each of them, so it ends up being ammonium. Oops. And then this part is hydroxide. So that's the name of this compound, it's ammonium hydroxide. Again, since both of them were off of table E, I took the names off of table E. Now I'm going to look at potassium cyanide. Potassium I know is an element. It's just K. There's only one charge to it, which is a +1 charge. I know that by looking off of my periodic table. And then I look at cyanide. So cyanide is right there, and that is Cn minus. It's a 1-to-1 charge, so it ends up being KCN. And here I have strontium phosphate. Looking up the elements on the periodic table, I know that strontium is just a +2, so I don't need to have more than one. I don't have more than one oxidation state, meaning I don't need to have Roman numerals. And the phosphate is actually off of table E. Let's see if we can find it right there. So strontium is Sr +2. I took that +2 from the periodic table. And phosphate, according to table E, is PO4 -3. So now I need to crisscross. I know I have three strontiums, and I also need to show that I have 2 phosphates. All right. So here I actually write the phosphate, the PO4. Don't leave out that 4 in parentheses. So I took that PO4 from in here, put those in parentheses, and then brought down the 2. So my formula for strontium phosphate is actually Sr3, and then in parentheses PO4 2. I need to make sure I have the PO4 in parentheses because it's off of table E and I know I have more than one of them. Now we're going to look at ternary ionic compounds, meaning, again, ionic compounds have more than 3 or more elements, and one of them has more than one oxidation state. So we'll look at SnOH2. Sn is tin. So here I can do Sn +2 or Sn +4. And that OH is hydroxide. It comes from table E. And that's OH -1. So I'll do both of them there just to see what happens. So for the first one, I have Sn. OH only has a 1 charge or -1 charge, so there's only a 1 there. And then here, if I bring down that 2, this ends up being OH2. I don't want to put the write it out as SnOH2 without parentheses, because that means I only have 2 hydrogens. I want to show that I have 2 hydroxides instead. So that's if I use the +2. If I use the +4, it would be SnOH4. So since I wrote this one correctly, this one ended up being it. So I'm going to get rid of this guy down here. And to write this out, I'm going to write out tin. I used the +2 version, so I'm going to write tin, Roman numeral 2, and then I'm taking the name from OH from table E, hydroxide. Okay, so that's tin 2 hydroxide. Looking here, I have FePO4. So if Fe has a +2 charge or a +3 charge, I'm going to write down both. So it's Fe +2, Fe is +3. And then PO4, I'm taking PO4 from the periodic table, from table E, and finding it there, PO4 -3, right there, and doing the other version down there. So if I use the first version, Fe +2, I would have Fe, the 3 would come down there, the 2 would go down there, so PO4 2. I can't reduce this down any further. The other one would be, if I took the 3 down there, Fe3, and the 3 down there, which is PO4 3, I can now reduce this down to FePO4, and I can drop the parentheses because I only have 1 phosphate. And this one ends up checking out, so this is the version that I'm going to use. I'll erase the other one since I don't need that anymore. So I used the +3 version here, so I'll write out iron, Roman numeral 3, phosphate. Sneak that P in there. Alright, so the name of this is iron 3 phosphate. Alright, so those are ionic compounds. Binary covalent compounds we looked at the beginning of Unit 2, and we need to use this prefix table. It's not listed in the reference table, so that's something that you do need to know. Going through again, these are both going to be binary means that there's two. Covalent means that they're both going to be nonmetals, so two nonmetals. Between the two nonmetals, where the least electronegative atom goes first, so that one will be listed on table S for you. If there's more than one of the first element, we add a prefix. Always use a prefix for the second element. So, for example, if I had, oops, get my pen out. If I had CO2, the first one, there's only one carbon listed there, so I don't need a prefix, so I can write out carbon. Since there's two oxygens, I use the prefix di. Later on, we'll go look at the rule, but if there is an oxygen, or excuse me, the prefix, the element begins with an O, which is just oxygen, I know I can drop or keep it as Di, dioxide. So that's what that third little rule means. Next, change the ending to IDE. If element begins with O, that's that rule that we just looked at. This third column describes how you would name those prefixes. So you actually end up dropping just the A's. So there's no A here, but there's an A with the other prefixes. There's no A there, there, and there. Alright? And we don't need to reduce down the formulas. So, for example, with this one, I wouldn't reduce this down to NO2 like I would for an ionic compound. I would keep it N2O4. Alright, so naming hydrocarbons. Again, these are just carbon and hydrogen. You'll use table P for the prefix, or the first part of the name, and then table Q for the last part of the name. So here are some examples. I have CH4. I have to figure out which one it fits into, an alkane, alkene, or alkyne. I know I only have one carbon here, so I can put these all into the general formula. So C1, that means that this would be H, the H would be 2 times 1, which is 2, plus 2, so that would be H4, which ends up checking out. So this ends up being an alkane. Alkanes end in ANE. There's one carbon, so I'm going to use meth. And then again, ANE, because it's an alkane. Let's see. Alright, then I have C3H4. I know the beginning of the name is prop, because there's 3 carbons. Again, you only use table P for the number of carbons. That's what's written right there for you that I just covered up. Only the number of carbons. So now I have to figure out which of the homologous years it fits into. So I'll put it into an alkane. I know the relationship would be C3. And then for H, I would do 2 times 3, which is 6, and then 8. So this does not match up. C3H4 is not going to be an alkane. I'll put it into an alkene this time. And you can actually just even look at this. However many carbons I have twice as many hydrogens. So here I'd have C3H6. This wouldn't match up. And of course, always double check to make sure the last one fits. So an alkyne, I have C3, and then H. So 2N would be 6, minus 2 would give you 4. So this ends up matching up. So the last name of this is Ein, and I grabbed that from right here. Okay. We'll go through and erase all those, and then now I have C5H10. I know I have 5 carbons, so that's going to be pent. I'll fill these in, and I actually know I can see the 5. I have 5 carbons and 10 hydrogens, so that actually fits right into the alkenes. So that ends up being pentene as its name. Right, so that's again if you have just carbon and hydrogen. If you have an organic compound, we actually do a video on this too. It's called the functional groups. So go back through and figure out how to name them from using the examples that are listed there for you. Alright. But again, this video was in Unit 2, and it's called Functional Groups. If you still have your notes from it, awesome, use that. And the last little part here is if we have acid. So if anything ends in the name acid, come over to Table K. So Table K has HCl, hydrochloric acid, HNO2, which is nitrous acid, HNO3, we added one more oxygen, we changed it to nitric acid, and then so on and so forth. So if it ends in acid, use Table K. Alright, so pretty much know how to name these compounds. Go back to previous videos if we need to. We definitely have videos on naming binary covalent, which was in Unit 2, naming hydrocarbons, which is in Unit 2 as well, and naming the functional groups, which of course is in Unit 2 as well. So we will practice this in class, and let me know if you need any help. Take care. Bye.